Hello and welcome to another video. In this video we're going to be working on sum of left leaves. And in this problem you're given a root of a binary tree and you want to return the sum of all the left leaves. A leaf is a node with no children, a left leaf is a leaf that is the left child of a node. So in this first example, these two are the left leaves because they're both left child of a node and they don't have any children. So you want to return 24. In the second example, you just have one node and the root as a default is not the left child because it's a parent and there is no parent of it, so it's not a left child, so you just want to return 0. And there's 1,000 nodes. So for almost all tree problems, you pretty much always want to do a depth first search. So I would say, like, as a default, use a depth first search traversal, that's recursive, and then sometimes, rarely, you can use a breadth first search. So in this one, depth first search works perfectly fine, and we basically just need to know what information to pass down and what information to pass, to return. So what are we passing down? Well, the only thing we really need to know is our node a left child, right? So it's like a yes or no. And the thing to pass up is just the total of all nodes, right? Like of all left children. So basically what we can do is we can start a traversal at the top and we can say, like, okay, we're at this node. It's not a left child, so we'll say, like, this is false. And then we can traverse any way you want, left or right. Like, sometimes it matters which way you do it, post, pre, whatever. In this case, it doesn't. So we'll just do a post. Yeah, I believe post. So we're going to go left, right, root. Yeah. And I usually do a post. Sometimes you do a pre or like in order or something, but typically I usually go with a post. So essentially we can say, okay, for this node, does it have a left child? It doesn't even matter, honestly. You can check for the left child. You can be like, okay, if it has a left child, recurse. If it doesn't, don't recurse. Or you can just have a default value for null, right? So when you go to a null child, you can just return 0, and that works as well. But regardless, so we go left, and we also have to make sure that, like, because this is a left child, we're going to pass down true. And here, we're going to check for this node, does it have any children? And if it has children, we recurse, but if it doesn't, then, so if it doesn't have children, and it's a left leaf, which we'll know because we're passing down, like, what leaf it is, left or right, then we want to return this value. So what we want to do here is we want to return a 9 up here. And then this left traversal's value will be a 9. Now we check the right side. So here, this node is a right child. So this is false. This is not a left child. And then it also has children. So we can go left. So this will be true because it is a left child. And this node doesn't have children. So we just want to pass up the 15 up here. And this node is false. It's a right child. It doesn't have children, but it doesn't have a left or right recursion. So here we want to just pass back 0, right? So, yeah. And then here, now we can pass up this total. So we can just keep passing up this cumulative total up to the root, and then the root will contain, like, the total. So here we have a 15 is the left, and the 0 is the right, so we just pass back 15. And now this node's left traversal will be 9, this node's right traversal will be 15, and we just pass back up 24, and that's the answer. That's basically all we need to do is a recursive DFS, have a Boolean value for is it a left child or not, and then we either return the node's value if it's a left child that has no children, or the total of the left and right recursion in any other case. And I'm just gonna go explore null nodes as well, and if it's a null node, I'll just return 0. So for example, like here, we will go left and right, and then we can just return 0 for these null nodes. So pretty straightforward. Okay. Get rid of all this. And so I'm just going to write down a recursive traverse function and then call it up here. You could probably modify this. I'm not sure how this gets called. I don't think you can modify this. In other languages, you can modify it just by giving it, like in Python, you can give it an optional variable like is left or something like this. That way, when it's called with nothing, it'll be defaulted to this. So you could do it all in here. But in Java, I think you probably want to write another one. So obviously, you can make it private and stuff. I don't really care about that stuff. So it's going to be a integer. It'll just return the total of the leaves. And we can call this like traverse or something. And it's going to take a tree node. And it will also take a Boolean value called is left child. So like I said, I will be going down to null nodes, so we can say like if node equals null, let's just return 0. Then we want to check for, is it a left child? Is it a left like a root? Like, is it a left child and has no children? So we could say if node.left equals null and node right equals null and is left child. Then we just want to return the node's value. So we can just return node value because we want the sum of all of these. Now we can recurse left and right. Even if it doesn't have children, it will just recurse to null nodes and give us 0. So we can say int left recursion, or we could actually just return this all in one thing. So we could return the left traversal, so traverse node left, and then the left node will be a left child, so this is true, so we want to pass it down true, plus traverse to the right, so node right, and now this won't be a left child, so we pass down false. So we can just do this all in one line here. And then here we just have to call that function with the root. So we can say return traverse root, and it's not going to be a left child in the beginning. So yep, and that works. And like I said, in another language that lets you pass default parameters, you can do this on one function. In Java, I don't think you can. But yeah, so pretty straightforward. And usually in a tree DFS, it's going to be O of n time because we visit every node once. And the space will be the recursive call stack. Like, even though we didn't make an array here, let's say our tree is like this. It just keeps going like this. So we're basically just going to recurse all the way down. So we'll have like the whole tree will be on the recursive call stack, which will be O of n space for a tree. So yeah, so let's write that. So time O of n, and this is the case for like 90+% of tree problems, is it's time O of n space O of n. That's ideally what you're looking for most of these. And this is kind of the template you want to follow, a recursive DFS, and you just call your function. Another thing that makes it a lot easier in a lot of these, and we could have done it here, is have some kind of global variable, like a class variable. So maybe have a class variable like result, it depends on your language. And then instead of figuring out what to return, just update that variable when you need to. And that makes it a lot easier, because then you don't need to like return the right thing. You don't need to make sure like I return the right thing. So what you could say is like, okay, anytime I'm at a node that's the left leaf, I'll just update my global variable to add that node. And then it's a lot easier to follow the logic. You don't have to like return the right things for all these things. So I definitely recommend that, at least to start. Have some kind of global variable up here that you just update in your traversal function. And then if you want to make it, better or whatever, I don't even know if it's better necessarily, then you can figure out what to return. But if you were to do it that way, you would just update your global variable right in here, and then you would just call traverse left and traverse right, but you wouldn't return anything. So it makes it a lot easier, because you don't have to figure out like, how do I return the right thing to make everything add up to what I want. So yeah. And yeah, it's gonna be all for this one. Pretty easy one. If you did like this video, please like and please subscribe to the channel. And if you have any questions, as always, write in the comments. And thanks for watching.